In this video, we're going to be revising the fourth chapter, which is quadratic equation. This is an important topic in every single paper that I've seen since 2016 board papers, sample question papers. At least one and sometimes 2 to 3 questions from quadratic equation. 6 basic concepts in this. We have lined it up with 13 questions, which are lookalikes of questions which have appeared in the past papers. So go through this entire video, solve those questions, solve the entire questions given in the NCERT textbook, in the exercise as well as in the solved examples. That should give you a good handle on cracking this particular topic. Here are the 6 concepts. Quadratic equation definition. Let's spend just 1 minute to understand what a quadratic equation is, and then look at the 3 methods of finding out the roots, which is basically factorization method, completion of squares methods, and the quadratic formula. Sometimes the question explicitly states that you need to use a completion of squares method, so let's learn that method. Discriminant of a quadratic equation and nature of roots of a quadratic equation. Subsequently, there have been quite a few questions, whichever have been tested, have always appeared as what I would call as word problems. It's not a concept per se. Essentially, information will be given about a train moving or a boat moving or some such thing, and then we need to frame an equation which will end up becoming a quadratic equation, solve the equation to find the answer. Let's get started with the first of the concepts, which is quadratic equation definition. Any equation of this form, ax square plus bx plus c equals 0, where a is not equal to 0, is the standard form of a quadratic equation. So keep this in mind. Something like x square plus 5x plus 6 equals 0 is an example of this format. Let's move on to the second one. But before that, let's solve one question, how this idea can be tested. Check whether the following are quadratic equation. So what we are going to do is, we're going to take the first one and the second. There are 2 parts to it. Expand both these things. They have enough room to expand. And check out whether the equation that we get is finally a quadratic equation. Let's do that. For the first one, I'm expanding the left-hand side term. That leaves us with x square. It's the form a minus b the whole square, which is a square minus 2ab plus b square. So x square minus 2ab in this case will be 2 into 5 into 2, which is 10. So minus 10x plus b square, which is 25. This is equal to x minus 2. So doing this part. So take all terms to one side. So you're going to get x square minus 11x plus 27 equals 0. So this is the form ax square plus bx plus c. So this is a quadratic equation. Let's quickly run through this process for the second one too, expanding this part. So leave us with x square minus 5x plus 3. So left hand side is definitely a quadratic equation. Let's look at the right hand side. X square minus 3x minus 4x plus 12 is what we have. So the right hand side also, if you look at it, is a quadratic equation. But when we take all of them to one side, does it still continue to be a quadratic equation? X square goes to the left hand side. X square will get cancelled with x square. The minus 7x goes to the left hand side. So minus 7x will become plus 7x. Plus 7x minus 5x is what we have. I'll take the 3 to the right hand side. So I'll make it as 12 minus 3. Without bothering too much about it, you can leave it at this stage or you can complete it. It's going to be 2x is equal to 9. There is no x square term at all. Therefore, this is not a quadratic equation. LHS was quadratic, RHS was quadratic, but the combined one is not, whereas the first one is a quadratic equation. Quickly summarize it, recap it in a printed form. Basically expanded the left hand side, which is the form a minus b the whole square, equating it to the right hand side. So net what we end up getting is an equation of this form, which resembles the standard form of a quadratic equation. So first one is a quadratic equation. Second one, LHS alone is a quadratic equation. RHS alone is a quadratic equation. Taken together, what we have is a linear equation in one variable. So this is not a quadratic equation, right? Let's move on from here. Let's move to the second concept. You're finding the roots of a quadratic equation using the factorization method. How does it work? If you have a quadratic equation, for example, which is, let's say, x square plus 5x plus 6 equals 0. Taking a very simple example to walk you through. So basically going to split this term 5x into 2 parts. Let's call those 2 parts to be equal to p and q. So p plus q should be equal to this middle term. We are splitting it. When we add those two, you should get the middle term. The product pq should be equal to the product of the first and the last term, which is equal to 6x square. I'll read it here. Factorization is done by splitting the middle term, the coefficient of x term, such that the sum of the two split terms is equal to the middle term, and the product is equal to the product of the first and the last term. The product is equal to 6x square. So obviously you guys by now know how to split it. This is going to be a 2x and 3x. Sum is going to be equal to 5x. Product is equal to 6x square. Right? This is the factorization method. Let's do one example to basically consolidate this. X square minus x minus 56 equals 0. So the sum is equal to minus 1. This is the sum. The product is equal to minus 56. We need to break this 56, right? Forget the sign for the moment. Let's look at how all can we write 56 as a product of two numbers. It's a very simple question. You don't need to go through all the steps I'm walking you through. But if the number is difficult, this is how you go about it. So 56 can be written as 1 times 56 because this product 1 into minus 56. Don't worry about the x square. It's there. It's not going to go anywhere. This is minus 1 times x. Not to worry about it. 1 into 56 is a 56. Forget the sign. 2 into 28 is a 56. 3 will not divide 56. 4 will. 4 into 14. 5 will not. 6 will not. 7 is going to 7 times 8. So these are all the 4 ways in which we can break this 56 into 2 parts. Now check out whether the addition or subtraction of 56 and 1 will give us this minus 1 or 1. 56 plus 1, 56 minus 1 is not going to give. This is not going to be. This is not going to be. 8 minus 7 will give us a 1. Whereas we want a minus 1. So minus 8 plus 7 will give us a minus 1 and the product is going to be equal to minus 56. So I'm going to factorize it as x square minus 8x plus 7x minus 56 equals 0. Right? You should know it by now because we're just a month away from the examination. But if you're still rusty about it, pick quite a few questions which are given in the NCERT textbook and get this factorization in place. So take x common as a term from this. X times x minus 8 plus 7 into x minus 8 equals 0. So I'm writing this entire thing here. This step, I'll call it as this step comes here. So this is equal to x minus 8 taken common from these two terms into x plus 7 is equal to 0. If x minus 8 is 0, x is equal to 8. If x plus 7 is a 0, x is equal to minus 7. So roots of this quadratic equation are 8 and minus 7. Quickly run through it in a printed form. We are factorizing this. This is going to factorize as minus 8 and plus 7. The sum is going to be minus 1. Product is going to be equal to minus 56x square. So that translates to the roots being minus 7 and 8. Let's move on. Here is a word problem where we need to frame the equation which in this case because we are in the quadratic equation will end up being a quadratic equation. Find two numbers whose sum is 17 and whose product is 72. Let's say those two numbers are x and y. So first step it says x plus y is equal to 17. And it says the second one the product xy is equal to 72. I'm going to write this y as a 17 minus x. So we're reducing the number of variables. Take the y from this and plug it in here. So we're going to get x times 17 minus x is equal to 72. Expand this. This is going to be 17x minus x square. This is equal to 72. Take all terms to one side. I'm writing it here. So it's going to be x square minus 17x plus 72 equals 0. We need to break this middle term minus 17 and get a plus 72 x square as a product. How is that going to happen? 8 times 9 equals 72. Minus 8 plus minus 9 is a minus 17. So it's going to factorize as x square minus 8x minus 9x plus 72 equals 0. If we take x as a term common from these two, we are going to get x into x minus 8 minus 9 as a term common from these two will leave us with another x minus 8. So that's going to be x minus 8 times x minus 9 equals 0. If x minus 8 is 0, x is equal to 8. X minus 9 is 0, x is equal to 9. So factorize this, we found the answer. What are the numbers? The value that x takes is either 8 or 9. If x is an 8, what is y? Y is 17 minus 8, which is going to be equal to 9. If x is a 9, y is equal to 17 minus 9, which is equal to 8. So numbers are either 8 and 9 or 9 and 8. So what are the two numbers that we are talking about? The numbers are 8, 9. Quickly run through it in a printed form. Sum of the two numbers is equal to 17. Product of the two numbers is a 72. We are rewriting this equation as y is equal to 17 minus x and substituting it here. So y is equal to 17 minus x has been substituted here. We got this quadratic equation. Factorizes as minus 8x minus 9x. Sum is minus 17. Product is plus 72. So values of x are 8 and 9. If x is an 8, then y is nothing but 17 minus x, which is 9. If x is a 9, y is 17 minus x, which is an 8. So it's 8 and 9 or 9 and 8. So the two numbers are 8, 9. Third concept that we are looking at is completing squares to find the roots. How do we go about it? What's the idea behind it? We have a quadratic equation, for example, x square minus 5x plus 6 is equal to 0. We will end up writing this equation, completion of squares, in such a way that it's of the form x minus p the whole square is equal to a q. So what we can do later on is take square root on both sides and therefore find the value of x. So the idea is to get this to an equivalent form, which is of the form x minus p the whole square. So you're completing a square. That's what this method is all about. Let's take a very simple example, walk through it and have a quick tip and then do a couple of more questions to round up this idea. Because we usually go by factorization or use the formula, but there have been a few instances where I've seen questions which have explicitly asked us to compute it using the completion of squares. So let's get a good handle on this. Here's a very simple question. It's a lovely question to factorize, but obviously we are not going to factorize it. We wanted to write this number x square minus 8x plus 7 in the form x minus p the whole square is equal to a cube. So we expand this x minus p the whole square. What are we going to write? I'm going to write it down here. X square minus 2px plus p square is what it is going to be. If we compare these two equations, obviously x square and x square are there. There is only one x term here because the right hand side is going to be a q here. So don't bother about it. It's a constant. So here it's quite evident that if you compare these two, 2p is equal to 8, which means the value of p is equal to 4. Now let's write this x square minus 8x plus 7 in such a way that we get a completed x minus p the whole square. So x minus p the whole square for us is a 4. So therefore, how it's going to be x square, we're going to get this completely done. X square minus 8x plus 4 square is a 16. That is what would have been an x minus p the whole square. We have an x square minus 8x plus 7, whereas we got it down here as an x square minus 8x plus 16. So all I'm going to do is, because we added a 16, let's subtract a 16 and add a 7. This number was added, this number is subtracted, we have written the 7 as it is. This is equal to 0. So x square minus 8x plus 7 has been rewritten in this form. This is nothing but x minus 4 the whole square. Minus 16 plus 7 is equal to minus 9 equals 0. So x minus 4 the whole square is equal to 9. Take square root on both sides. So you'll get x minus 4 is equal to plus or minus 3, which means x is equal to 4 plus 3, which is a 7. Or x is equal to 4 minus 3, which is equal to 1. The roots are 1 and 7. I'll recap it once in a printed form so we get a good handle of it. Right? What we're going to do is we're going to write this entire quadratic equation to resemble this x minus p the whole square equals q. So the first step is to determine the value of p. Expand this x minus p the whole square. This is that expansion. So if we compare it with this equation, it's quite evident that this 2p is equal to 8. If 2p is equal to 8, then p is equal to 4. So step 1 in doing this is finding the value of p. I'm going to give you a quick tip at the end of the slide as to how to get to that without even writing this. Now, we know that the value of p is equal to 4. So we're going to write this x square minus 8x plus 7 as x square minus 8x plus this p square, because x square minus 2px plus p square is what is going to complete it as x minus p the whole square. So we've added a 4 square to it. Let's subtract a 4 square. So nothing is lost. X square minus 8x plus 7 with a 16 added, 16 subtracted is still going to be the same. But this part is going to be x minus 4 the whole square. 4 square is the 16 plus 7. So x minus 4 the whole square equals 9. X minus 4 is equal to plus or minus 3. X is equal to 7 or 1. Quick tip is this. If the coefficient of x square is 1, the standard form of a quadratic equation is ax square plus bx plus c equals 0. If a ended up being 1, then what we'll have is x square plus bx plus c is what it will turn out to be. So the coefficient of x square is 1. And the quadratic equation therefore is of the form x square plus or minus b, because we had a minus 8x, it could have been a plus 8x in some cases. If it is x square plus or minus bx plus c equals 0, the value of p is going to be equal to half of b. Whatever is the value that you see here for b, half of that is going to be the value of p. Keep this as a tip. I'm going to do 2 more questions to consolidate this idea. So let's see if we can quickly get to that without writing all of these extra steps. Right? Let's move on to the next one. Find the roots of the quadratic equation by completing the squares. The last one was easy and the tip worked when the coefficient of x square was a 1. Here we have the coefficient of x square as a 2. No sweat. Divide this entire equation by 2. Because we're used to seeing it in one way, let's see it in that way. So if I divide this by a 2, you're going to get x square minus 7 by 2x plus 5 by 2 equals 0. So now this is again of the form x square plus or minus bx plus c equals 0. I'm going to use the tip directly. Tip is what? The value of b is the value of p. We want x minus p the whole square. So the value of P we said is equal to half B. So in this case, therefore, it's going to be half into, what is the value of B? That is equal to 7 by 2. So value of P is equal to 7 by 4. Value of P is 7 by 4. We're going to write it as x minus P the whole square form. So x minus 7 by 4 the whole square. What would this have expanded as? X square minus 2ab is 2 into x into 7 by 4, which would have been minus 7 by 2x. Plus there is going to be a P square, that is 7 by 4 the whole square. That is all included here. So you've added a 7 by 4 the whole square, subtract that 7 by 4 the whole square here, plus 5 by 2 equals 0. This is the same as this equation. Let's keep this as it is. We're not going to do anything with this. We want it as a full square. Let's not expand it again. That'll be stupid. X minus 7 by 4 the whole square minus the 7 by 4 whole square can be written as 49 divided by 16 plus 5 by 2 is equal to 0. We'll take all of that to the space. Right. So this is going to be x minus 7 by 4 the whole square is equal to 49 by 16 goes to the right hand side as plus minus 5 by 2. So take 16 as a common denominator. It's going to be 49 minus 5 times 8, which is equal to 40. This is equal to x minus 7 by 4 the whole square. 49 minus 40 is equal to 9. 9 by 16 is what we have at the right hand side. Take square root. If we take square root, this is going to be x minus 7 by 4 is equal to plus or minus 3 by 4. We'll solve for x in a subsequent slide, but this is the process of completing the square. So what is going to be the value of x? X is equal to 7 by 4 plus 3 by 4. X is equal to 7 by 4 minus 3 by 4. When I'm recapping it in a printed version, we'll get to the final value of x. Right? Is the idea clear? How did we go about it? We spotted it by, we converted this equation to have the value of a to be equal to 1. The coefficient of x square should be 1. Then we said p is equal to half b, having done that. So what is b? B is equal to 7 by 2. So value of p is going to be half of 7 by 2, which is 7 by 4. So next step, x minus 7 by 4 the whole square. This would have had the 7 by 4 square in it as p square. So subtracting that and writing this 5 by 2. Then we had a completed square. Finding out the value of x is very simple. Recap it in a printed form. The equation has been rewritten to have the coefficient of x square as a 1. That's step number 1. Step 2, what is the tip? The tip is basically p is equal to half b. Keep this in mind. B is equal to 7 by 2. So p is equal to half of that, which is 7 by 4. I've run through this entire process in a printed form. Don't even worry. We know that p is equal to half b. So p is equal to 7 by 4. That's done. So next step is writing it as x minus p the whole square. Here is the tip. Again, reiterating the quick tip, which is the coefficient of x square is 1. Then the equation is of the form x square plus or minus bx plus c equals 0. Then p is equal to half b. Use this. This is going to save you a lot of time. Right. We're going to go to the next step. So it's essentially going to be x square minus 7x plus 5 by 2 equals 0, which is our modified version of this equation, is essentially x minus 7 by 4 the whole square minus 7 by 4 square plus 5 by 2. This minus 7 by 4 whole square plus 5 by 2 is nothing but minus 9 by 16. Take it to the right hand side. Take square root. X minus 7 by 4 is a plus or minus 3 by 4. If it is a plus 3 by 4, the answer is 10 by 4, which is equal to 5 by 2. If it's a minus 3 by 4, then it is 4 by 4, which is equal to 1. The roots are 5 by 2 and 1. Let's move on. Using completing the square method, show that this equation has no solution. Completing the square is going to leave us with something of the form x minus p the whole square equals a q. When will this not have a solution? This is not going to have a solution if q is negative. If I ended up showing that, for example, x minus 3 the whole square is equal to minus 40 or something. Square of a real number cannot be negative, which means it does not have a solution. So at the end of completing the square, because they are saying that show that this has got no solution, we will definitely get a negative number on the right hand side. Let's check out whether that happens, right? So again, I'm using the quick tip. What is the quick tip? P is equal to half b. What is b here? 6. So p is equal to half of 6, which is equal to 3. So our equation is going to be x minus 3 the whole square. That's our starting point. So the p square would have been a 9. We'll have to subtract it. Minus 9 plus 12 equals 0. This is the same as this equation. If you want, we can quickly ratify it once more. X square minus 6x plus 9 is the expansion for it. We're subtracting a 9 here plus a 12. So this got back the same old equation. So this is absolutely right. So this minus 9 plus 12 is a plus 3. Goes to the right hand side. So you have x minus 3 the whole square equals a minus 3. Square of a number, if it is negative, you won't have real solution. So we proved that this got no solution. Summarize it in a printed form. I have not used the tip, but if you use the tip, it's very straightforward. P is equal to half B. I'm recapping the tip once more, right? Reiterating the quick tip. If it is written of the form x square plus or minus bx plus c equals 0, P is equal to half B. So half times 6, P is equal to 3. So go and write it as x minus 3 the whole square minus 9 plus 12 equals 0. So x minus 3 the whole square is a negative number. So it's got no solution. So done 3 questions. Take a few more things that you know which can be factorized. Just use this completion of squares method. To get a question of this kind, it should definitely be cracked. Let's move on. Let's look at the concept of a discriminant before going to the third method of finding out the solution, which is using the quadratic formula. For a quadratic equation of the form ax square plus bx plus c equals 0, its discriminant is b square minus 4ac. So here is a question to quickly consolidate it. Find the discriminant of this quadratic equation. Let's expand it and first see it as a quadratic equation. This is the form a plus b the whole square, which is a square plus 2ab plus b square. So x square, 2ab in this case therefore is going to be 10x plus b square is equal to 25. This is equal to 10x minus 2 into 3, which is equal to 6. Take the 10x to the left hand side, gets cancelled. We have x square, the 6 comes to the left hand side, plus 31 equals 0. What is the discriminant? Discriminant is b square minus 4ac. Is there an x term at all here? No. So that's going to be 0 square minus 4 into 1 into 31. So discriminant of this quadratic equation is a negative number, which is minus 124. Quickly recap it in a printed form. This expands as x square plus 10x plus 25. The right hand side is 10x minus 6, consolidates as x square plus 31. A is equal to 1, B is equal to 0, C is equal to 31. So B square minus 4AC, the discriminant, is a minus 124. Let's move on. Concept 5 is finding the roots of a quadratic equation using the quadratic formula. Where you cannot factorize it, you can either use completion of squares or you can go with the quadratic formula. The quadratic formula is nothing but a formula which has been derived for ax square plus bx plus c, writing it as x square plus b by ax plus c by a equals 0. You can apply that x minus p the whole square here. In this case, it's going to be an x plus p the whole square format, and you will end up getting this. Right? We have done a video about this in our online course. You can go and watch it, or you can check the NCERT textbook. The derivation for this is given. So roots are minus b plus root of b square minus 4ac by 2a and minus b minus root of b square minus 4ac by 2a. Quickly run through this. Find the roots of the quadratic equations if they exist using the quadratic formula. Method is explicitly stated. What do you mean by if they exist? Right? Look at this formula. Go back to the formula. The formula has got a square root term. Square root of a negative number is not real. We know that. So this b square minus 4ac, if it is less than 0, we will have no solution. If it is equal to 0 or if it is greater than 0, then we will have a solution. So first step in all of these cases, we're going to check whether the discriminant is positive. Start with the first equation. We'll check the discriminant in this slide and compute the roots in a subsequent slide. We're going to check the discriminant. Discriminant is equal to b square minus 4ac. This is b square minus 4ac. B for us is a minus 10. So minus 10 the whole square minus 4 times a is 1 into 21. Minus 10 square is 100. 100 minus 84 is equal to 16. So this has a valid solution. We'll compute the roots in the subsequent slide. Just hold on. Let's go to the second one. We'll again compute the discriminant. B square in this case is a 2 square minus 4 into a is 1 and c is equal to 4. So discriminant therefore becomes 4 minus 4 into 4 is a 16. This is equal to minus 12. Discriminant is negative. Obviously square root of a negative number because the roots are computed as square root of b square minus 4ac. b square minus 4ac is negative. This equation is not going to have a solution. So let's compute the solution for it in the subsequent slide. If a solution exists where b square minus 4ac is greater than or equal to 0, then the roots of the quadratic equation are given by this. I'm going to plug in the value minus b, which is minus of minus 10, plus or minus square root of, we computed b square minus 4ac to be a 16. I'm going to use it directly without wasting time, divided by 2 into a. So this is going to be equal to minus of minus 10 is a plus 10, plus or minus 4 divided by 2 will be the roots. 10 plus 4 by 2 is one root, which is 7. 10 minus 4 by 2, which is 6 by 2. 3 is the other root. So 7 and 3 are the roots. So a equals 1, b equals minus 10, c equals 21. Computed this to be equal to a 16. From there, we are finding out the roots by plugging it into this formula, which is 3 and 7. Let's move on to the second one. We computed the b square minus 4ac to be a negative number. B square is 4, 4ac is a 16, 4 minus 16 is equal to minus 12. Because the discriminant is negative, this quadratic equation does not have any solution. Let's move on. Find the value of k for which one root of the quadratic equation is 2. They mention something like this, right? If 2 is the root of this quadratic equation, if I substitute 2 in the place where x occurs in this equation, it should satisfy this equation, right? If it's a root, it's a solution to the equation. So plug in x as 2. If we do that, what do we get? K into 2 square minus 8 into 2 plus 4 is equal to 0 is what it becomes. 2 square is a 4. 4k minus 16 plus 4 is equal to 0. Minus 16 plus 4 is a minus 12. Goes to the right hand side as plus 12. 4k is equal to 12. So k is equal to 3. So for what value of k? What is the value of k for which 2 is going to be one of the roots? Then k is equal to 3. 2 is going to be one of the roots of this quadratic equation. Summarize it in a printed form. 2 is one of the roots. Then substituting it will satisfy the equation. So replace x with 2 in the equation. What do we get is basically this. It's 4k minus 12 equals 0 or k is equal to 3. Let's move on further. Here are what I call as the word problems. These are tested quite often in about 3-4 question papers. I've seen such questions. Right? A motorboat whose speed is 20 kilometers per hour in still water takes 1 hour more to go 48 kilometers upstream than to return downstream. So it's traveling a distance of 48 kilometers upstream, 48 kilometers downstream to the same spot. Find the speed of the stream. I'm going to assign a variable which is the speed of the stream, which is x kilometers per hour. Now let's look at it. The boat is going upstream. When it is traveling upstream, the speed is going to be still water speed minus the speed of the stream. So upstream speed is equal to 20 minus x. Downstream speed is equal to 20 plus x. So how long will it take to travel 48 kilometers upstream? Distance by speed, which is 48 by 20 minus x. How long will it take to travel downstream? That's going to be the same distance. The speed is right now 20 plus x. Downstream speed is more, so time taken is going to be lesser. How much lesser? It takes 1 hour lesser. So difference between the time taken to travel upstream and downstream is equal to 1 hour. So upstream time, this is time for upstream, this is time for downstream. This difference is equal to 1 hour. Take 20 minus x into 20 plus x as a common denominator, which is going to be actually 400 minus x square. Let's take it all in one go. And then the numerator, take 48 as a common term between these two. You'll have a 20 plus x and then minus of 20 minus x, which is going to leave us with a minus 20 plus x. This entire thing is equal to 1. So 20 gets cancelled with minus 20 to leave us with 2x. So the numerator here is going to be 96x. I'm going to cross multiply this. This is going to leave us with 400 minus x square. Take all terms to one side. We'll get x square plus 96x minus 400 equals 0. Very easy question to factorize. 400 is 4 times 100. 96 is 100 minus 4. It's going to factorize therefore as x plus 100 times x minus 4. This is equal to 0. Which means the values of x are minus 100 or it's going to be equal to 4. Speed cannot be negative. So speed of the stream is equal to 4 kilometers per hour. Quickly summarize it right from framing the equation. The variable that I have taken is the speed of the stream to be x. So upstream speed is 20 minus x. Downstream speed is 20 plus x. Time taken to travel upstream is going to be distance divided by the speed. Time taken to travel downstream is this. Downstream it's going to take lesser time because the speed is more. So difference between those two is equal to 1. Taken 48 as a common term. So it's going to be 1 by 20 minus x minus 1 by 20 plus x. This is equal to 1. So take 20 minus x into 20 plus x as a common denominator. This is what we have in the numerator. These two get cancelled to leave us with 48 into 2x, which is 96x. We have cross multiplied this term to get a 400 minus x square. So quadratic equation that we have got is x square plus 96x minus 400 factorizes as x plus 100 and x minus 4. So speed x is going to be either plus 4 or it's going to be minus 100. Speeds cannot be negative. So speed of the stream is equal to 4 kilometers per hour. Let's move on. One more word problem. A train covers a distance of 105 kilometers at a uniform speed. Had the speed been 5 kilometers per hour, it would have taken 30 minutes lesser for the journey. Find the original speed of the train. Again, only one variable. I'm going to take the original speed as x kilometers per hour. Let's start with that. So if it is traveling at x kilometers per hour, it would have taken a time of 105 by x. This is the usual time. Let's call it as t1. If it travels at x plus 5, then the time taken is going to be the distance divided by the new speed, 5 kilometers more. X is the original speed, x plus 5 is the new speed. Obviously, the time taken the second time will be lesser because the speed is more. So difference between these two is equal to 30 minutes. We have the speeds in kilometer per hour. So let's convert this 30 minutes into number of hours, which is going to be half an hour. So all of this time taken in number of hours minus time taken in number of hours is equal to the difference, which is equal to half an hour. Take x into x plus 5 as a common denominator of the left hand side. X times x plus 5. 105 in the numerator is a common term for both the left and right side terms. So it's going to be x plus 5 minus x. This is equal to 1 by 2. X gets cancelled with x. Let's cross multiply. This is 105 into 5 into 2, which is nothing but 105 into 10, which is equal to 1050. Let's keep it on the right hand side. This goes to left hand side. We'll keep it as x times x plus 5. Expand and take everything to one side. We'll have x square plus 5x minus 1050 equals 0. On the face of it, it looks like a difficult term to factorize. Not so much. 35 into 3 is 105. 35 into 30 is a 1050. So 35 minus 30 is 5x. 35 into 30 is 1050. Factorize as x plus 35 times x minus 30 is equal to 0. So values of x are x equals minus 35 or x is equal to 30. What is x? The usual speed of the train. Speed cannot be negative. So x is equal to 30 is the answer. Quickly frame the equation in a printed form. Taking the variable as x as the usual speed of the train. Distance covered is 105. So time is distance by speed. Usually it takes 105 by x. When the speed increases by 5, new speed is x plus 5. So time taken is going to be 105 by x plus 5. This is 1 hour lesser, half an hour lesser, 30 minutes lesser. So difference between these two time taken is going to be equal to half. This is the starting point for our equation. Step 1. X into x plus 5 is a common denominator. Therefore, these two x will get cancelled. Cross multiply. You're going to be left with 1050 is this value equals x square plus 5x. Take everything to one side. Now we are used to seeing a quadratic equation the way we usually see. This is going to factorize as x plus 35 into x minus 30. So speeds are minus 35 and 30. Speeds cannot be negative. Therefore, the usual speed of the train is equal to 30 kilometers per hour. Let's move on. These are usually 3 or 4 mark questions. So get conversant. It's usually going to be boats in stream, speed of train, these kinds of questions. When all were these concepts tested, look at the number of questions that have come. In a board paper 2016, there have been 3 questions. 2017, there have been 4 questions. There have been internal choice, 18, 3 questions. Quietal, 19, 4 questions. So quadratic equation is a very, very important topic. You just cannot wish it away. It's not a tough topic either. Last one is nature of roots. This is the last of the concepts you're going to be looking at. A quadratic equation ax square plus bx plus c equals 0 has 2 distinct real roots when the discriminant is positive. 2 real and equal roots when the discriminant is 0. If the discriminant is negative, it's got no real roots. Right? Let's quickly run through these questions. I'm going to quickly find out and say what is the thing. In each of these cases, we'll check out whether real roots exist. If they exist, we'll compute the real roots in a subsequent slide. So all that I'm going to do in this slide is find out b square minus 4ac. So here b square minus 4ac is minus 5 square minus 4 times 3 times 4. Minus 5 square is a 25 minus 12 into 4, which is equal to 48. This is equal to minus 23, which is less than 0. Discriminant is negative. We don't have a real root for this equation. Let's go to the second one. B square is minus 4 square minus 4 times 2 times 2. So this 4 into A into C. Minus 4 square is a 16 minus 4 into 2, 8 into 2, 16. 16 minus 16 equals 0. If it is equal to 0, definitely has roots. What kind of roots? Real and equal roots. So look at the third one, which is minus 7 square, which is b square, minus 4 times 1 into 12. A is equal to 1, C is equal to 12. 49 minus 4 into 12, which is 48, is equal to 1. This is greater than 0. So definitely has roots, real and distinct roots. So for the second and third, we'll compute the roots using the formula subsequently. Right now, let's quickly run through the discriminant for the first one. A equals 3, B equals minus 5, C equals 4. So, you're computing B square minus 4AC, which is negative, so no real roots. Move on to this case. We're finding out B square minus 4AC, which ended up being 0. So, let's compute the roots. The roots are computed using this formula. Minus B is minus of minus 4 plus or minus square root of, we anyway found out the value of B square minus 4AC, which is a 0, divided by 2A, A is equal to 2, so 2 times 2. Minus of minus 4 is a plus 4, 0 added and subtracted, no difference, 4 by 4 is equal to 1. So the two roots are equal because the discriminant is 0. What is the value of the root? The value of the roots is equal to 1. Let's move to the third one. Here, this is recapping it in the printed form. Third part, A is equal to 1, B equals minus 7, C equals 12. We got a positive B square minus 4AC, which is equal to 1. So let's compute the roots. The roots are going to be minus B, which is minus of minus 7, plus or minus root of, we have computed B square minus 4AC, which is a 1, divided by 2A, which is 2 times 1. So this is equal to minus of minus 7 is plus 7, square root of 1 is a 1, 7 plus or minus 1 divided by 2. 7 plus 1 by 2 is 8 by 2, which is 4. 7 minus 1 by 2 is 6 by 2, which is equal to 3. So roots are 4 and 3. Let's move on from here. These are the values of the roots in a printed form. The last question, find the value of k for which this quadratic equation has equal roots. When will a quadratic equation have equal roots? It's going to have equal roots when b square minus 4ac is equal to 0. What is b? b is k. So k square minus 4 into 3, which is a, into 3, which is c. This is equal to 0. So translates to k square, 4 into 3, 12, 12 times 3, 36. K square minus 36 equals 0, or k square is equal to 36, which means the value of k is equal to plus or minus 6. So for what values of k will it have real and equal roots? When k is a 6 or when k is a minus 6, it's going to have real and equal roots. A is 3, b is k, c equals 3. It will have real and equal roots when the discriminant is 0. Computing the discriminant to be k square minus 36, equating it to 0 to find the value of k. Right. When were these concepts of nature of roots tested? It was tested in all of these cases. Right. So there have been cases of years where we had questions not touching the nature of roots, which we saw, and on top of it, you also had questions which tested this. And in the most recent sample paper, we have questions testing nature of roots. Right. So quickly, key things to note. Any equation of the form ax square plus bx plus c equals 0 is a quadratic equation. And find the roots using three methods. By factorization, just splitting the middle term. By completing squares, where we write it in the form x minus b the whole square equals a q. And third, by using the formula minus b plus or minus square root of b square minus 4ac by 2a. So completed 4 concepts in this. Concept 5 is discriminant. Discriminant is b square minus 4ac. Concept 6 is nature of roots. Nature of roots essentially states that if b square minus 4ac is less than 0, you'll have no solution, no real solution. If it is equal to 0, we have real and equal roots. If it is greater than 0, then you'll have real and distinct roots. Right? So important topic, takes about 30-40 minutes to quickly run through this concept. Solve about 8-10 questions. Get conversant with it. Best wishes. Before you leave, do 2 things. Sign up at online.maxtute.com for CBSE online coaching for class 10 maths. Takes less than 5 minutes in all of 3 steps to get started. And do one more thing. Subscribe to this channel, youtube.com/maxtute, and spread the word about this channel to your friends and classmates.